Hi guys, so today's lesson is on the mole. The mole is something that we need to use in chemistry, and so let's get started. And so here is a mole. Right here, big, gigantic, ugly mole. Oh, but that's not the kind of mole we're going to talk about. This is better. That's a better mole. Still not what we're going to talk about though. There we go. There's the mole. A nice, fuzzy, little, furry creature, big claws that digs in the ground. Still not what we're going to talk about. The chemist mole. That's what we need to talk about is the chemistry mole. And we can thank this gentleman for the mole. His name is Amadeo Avogadro. He was an Italian scientist, and he laid the foundation. He did a lot of work and laid the foundation that led to the development of the mole, or the mole concept as we understand. And so what is the mole concept? Well, um, it's a lot of things, but in simple terms, it's a number. And so it is this number. 1 mole is equal to 6.02 times 10 to the 23 particles. You need to memorize that number. Matter of fact, this number is called Avogadro's number. It's named after sorry about that. It's named after Amadeo Avogadro, so it's called Avogadro's number. And so you need to know that this is Avogadro's number. And so that's a very important number, 6.02 times 10 to the 23rd. Remember, on October 23rd, we did some mole stuff, even though we weren't talking about the mole yet, because that is mole day. It's 10/23, October 23rd is mole day. And so anyway, Amadeo Avogadro is an important scientist, and he developed this number. But let's kind of bring something that you understand. And so names that represent numbers. So here you go. Here's an object that you know, and that's eggs. How many eggs is it? Well, you might say that there's 12 eggs in there, but you also might say that there are a dozen eggs. That name dozen represents 12 objects. And so we buy eggs by the dozen oftentimes. Another example is a gross. If you look here, we have some pencils, and these are actually packages of pencils. So here's a package of pencils right here, and then another package of pencils here, another package of pencils here, and you can actually see right here on the package there's 12 right there. There are 12 pencils in this package. And there are 12 dozens of these packages. There are 12 dozens, which is 144. That's what a gross is. Last example is this. And, you might buy a box of paper, and in the box of paper, they would have the individual packages of paper. And that package of paper is called a ream of paper. You could have a ream of anything. In this case, it's a ream of paper. A ream of paper is 500 pieces. We buy paper. We wouldn't buy paper in dozens. 12 pieces of paper would not be enough to do anything. But we can buy papers in reams, and so 500 sheets is a ream. We would not buy eggs in reams because probably most of them would go bad before we would use them. And so these are just names that represent numbers. The mole is the same kind of thing. The mole is simply a name that represents a number, 6.02 times 10 to the 23rd, of whatever you're talking about, pencils, eggs, paper, in our case, atoms or molecules is what we're going to be talking about. It's a really, 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 really big number. If you wrote that number out, then you would get 602, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21 total zeros. And then we put our commas in here. We'd have a comma here, 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 and here. So this would be the thousands place right there. That's the millions place right there. That's the billion, the trillion, quadrillion. I think this is heptillion there, and this is actually the sextillion. So 602 sextillion, a huge, huge, huge number. Why do we need a number so big? Might be the question that you're asking. And so let's talk about why we need a number so big. But let's do some examples first on how big that number is. And we may have done some things like this in class before on mole day. But anyway, let's do it again. How big is a mole? If I made you a millionaire, and you spent $1 billion every second, how long would it take for you to be broke? So if I make you a millionaire, you have that many dollars, 6.02 times 10 to the $23, because one mole, if you have a millionaire, you have $1 million. If you have a mole of dollars, you have that many dollars. And let's do the math. So if you have that many dollars and you spent $1 billion every second, we're going to do our conversion. We have dollars on top here on the mole, on the 6.02 times 10 to the 23 dollars. We'll put dollars on the bottom. And $1 billion would be 1 times 10 to the 9 dollars. And that occurs every second. So in every 1 second, we spend $1 billion. And remember, that's what our equalities are. Our conversion factors effectively is an equality where the top and the bottom are being equal to each other. In 1 second, we spend that much money, so we've made them equal to each other. And let's just convert our seconds into longer units of time. So seconds on top, we'll put seconds on bottom. And we'll put 60 seconds on bottom, minutes on top. 1 minute is 60 seconds. Continuing on, we'll go from minutes to hours, which is 60 minutes to an hour. We'll go from hours to days, 24 hours in a day. We'll go from days, we're going to move down because we're out of room, 365 days in a year. We're going to make an assumption that you have 80 years in your lifetime. So if you spent $1 billion every second, how long would it take for you to spend a mole of dollars? Do that math and you get 238,616 lifetimes to spend your mole of dollars if you spent $1 billion every second. Now, think about that for a second. $1 billion. You probably have a hard time imagining $1 billion. It's crazy how big $1 billion is. And you're spending that much money every second, and it would take you 238,000 lifetimes to spend a mole of dollars. That's a big, big number. Let's do one more example. Would Cowboy Stadium, would Jerry's World hold a mole of sand? So if I had a mole of sand particles, would they fit in Cowboy Stadium? Well, let's make an assumption. There's all different kinds of sand and different sizes of sand. Let's just take a typical grain of sand, and let's say that it has a volume of 5 times 10 to the negative 6 cubic centimeters. And so that would be 1, 2, 3, 4, 5, 6. There we go. It'd be this many cubic centimeters. That's really small. That's a millionth of a cubic centimeter. So remember, a cubic centimeter is a milliliter. And so you've measured milliliters in our graduated cylinders, and a milliliter is not very big. And so we're taking 5 millionths of a milliliter, and that's a grain of sand. That's really, really small. Cowboy Stadium, I just looked this information up on the internet. Cowboy Stadium has a volume of 2.9 million or 2,900,000 meters cubed, and not centimeters cubed, but meters cubed, which are much larger than centimeters cubed. So let's do the math. If 1 grain of sand is 5 times 10 to the negative 6 centimeters cubed, and I have a mole of them, I'm going to multiply that by a mole, and that'll give me the volume of a mole of sand, which is 3.0 times 01 times 10 to the 18 centimeters cubed per mole of sand. So that's my volume per mole of sand. And let's do the math. That's my volume per mole of sand. We need to convert that centimeters cubed to meters cubed, because that's how I've got my volume of the Cowboy Stadium. And 1 times 10 to the 6 centimeters cubed is 1 meter cubed. If you don't know how to do that cubic conversion, just come see me and I'll tell you how to do that. 1 meter cubed is 1,000,000 centimeters cubed. And 1 Cowboy Stadium has a volume of 2,900,000 meters cubed. So you can see our units here that work out. Unit-wise, we'll get centimeters cubed canceling centimeters cubed. We'll get meters cubed canceling meters cubed. We'll have Cowboy Stadium on top, and we'll have per mole of sand on bottom. So how many Cowboy Stadium per mole of sand is what this is going to tell us. How many Cowboy Stadiums per mole of sand? And the answer is 1,038,000 Cowboy Stadiums per mole of sand. Per mole of sand. That's a lot of Cowboy Stadiums that we have to hold a mole of sand. 1 million of them. Okay, so anyway, and that's and sand's really small. And so 1,000,000 Cowboy Stadiums to hold a mole of sand. Anyway, so why do we use the mole? Why do we have to use such a number that is so big? Well, it's because atoms are so small. Atoms are tiny, very tiny. Okay, as a matter of fact, if you look here, there's a quarter in that picture, and this bar right here, for example, that bar is 1 mole of copper. Remember, a mole of sand would fill 1,000,000 Cowboy Stadiums. That's a mole of copper. How small are the atoms if this is the size of 1 mole of copper? So the reason why we use the moles, because they're just the atoms are really small, and we have to have this massively large amount of them to even hold them, to be able to even be able to see them. You wouldn't even see 1,000,000 atoms. They'd be too small for you to see. So we have to have these massively large numbers to see and handle atoms because they're just so tiny. So that's why we use the mole. Okay, that's the end for this lesson.